Okay, next we are going to cover filtering by values. So what is meant by that? So instead of saying I want the data based upon the column heading or the row index, what I'm saying is I want data that matches a certain criteria. So let's say I wanted all of the data that was all of the genes that were expressed in AFD. So in Microsoft Excel, which you might be familiar with, you would turn on the filter option and then you could set a specific filter. And so if I want only the genes that aren't expressed in AFD, I could do something like that. So you can also do this filtering in Pandas very easily. And so the way that works is that you use this type of syntax. So you can see that we have returned 8,721 rows. So we've excluded most of the many of the rows, and we return all of the data for all of the other columns. So if you only wanted to see that data for ADA, you would just follow this standard procedure to filter out by column names. So you'll notice that there's a couple things that we've done. One is we used we have indicated to Pandas that we're interested in this column ADA by using the dot operator. So this says I want the columns that are equal to 0. I want the data in ADA that is equal to 0. And then you'll notice that we use this expression, this conditional expression, and we put it within the slicing operator. And so that has returned a data frame that is filtered out based upon that condition. You can also, instead of using the dot operator, you can also use the slicing operator. So the slicing operator here says use the data from the ADA column and only look for the values that are 0. And so that would return the exact same thing. In general, I use the dot operator, but sometimes a column name might have a space in it, and if it has a space in it, then you have a problem with using the dot operator, and so then you would have to use the slicing operator instead. So you could also do doesn't equal 0. So remember the double equal sign is the comparison equals, and then for Pandas you use the exclamation point and then the equals, and then that says does not equal 0. You can also do greater than. So if you wanted to know all of the ones that are greater than 0 or greater than 50, that's all pretty straightforward. Gene names. So if you wanted to search for a specific name of a gene, you give it the right name. If you mess up, then, oops, not greater than, I wanted equal. Then I get an empty data frame because there's no genes with that name. But if I gave it the right name, then it returns the single row that has that name. So gene name also has, so if I wanted to do something like this, so we've used is in before. So we use that with nucleotides to make sure that they're a valid DNA sequence. We use it with lists, but you cannot actually use it that way in order to work. But if you wanted to do something like that, there's this built-in method of the column series that acts the same way. So many times Pandas has re-implemented some of the things you might be used to using. So if you do a little searching on Google, you might be able to figure that out. And so now I've returned all of the genes that have the name either globe 5 or globe 6. You can also do multiple conditions. So another way to do this is that I can do something like this. So if gene name equals globe 5, we see that works. Globe 6, we see that works. And if we want both of them, then we use a OR. So, you might think it looks something like this. Again, this is kind of like a subtle difference of pandas that you have to get used to. The OR operator for pandas is this ampersand. So then we can do something like this. So now we have two different conditionals. And so if either one of these occurs, it should work. Unfortunately, this also doesn't work. And so another thing that you need to do in pandas is you have to wrap each conditional in a parentheses. So I'm putting open and close parentheses around each conditional. And so, wait, why did that work? I used the amp. Sorry, the ampersand is the AND operator, and then the OR operator is this pipe symbol. So this is AND, and then this is OR. So you could also do something like this. So if I wanted to return all of the data where there's no expression in ADA and there's no expression in the URX class, then I could do something like this. So how exactly is filtering work? So let's talk a little bit more about that. So we know by now that if I wanted to return if I wanted to filter it for all of the rows where the gene name is equal to globe 5, I can do that. But let's see what is actually returned by this conditional right here. And so what is returned is a series where for each index it's a Boolean, which is either true or false. So it is row. So this conditional is basically done on every single row in the table. And so if the gene name equals globe 5, it would be true, but it's not for this row, so it's false right here. So so if we filter this to just look at indexes 7903 to 7905, we see, sorry, I meant to do this. Then we see that this index right here is true. And so that is why this row is returned, is because this is the only row that has a true value within this array. And so that's how the filtering works, is that if you send it an array for each index of true or false, then it just filters out to either print it or not print that, include that row. You can also use, so another example, so let's say I wanted to, let's say I wanted to find all of the genes that had the letters DOP in their name. So a way to do that is that you can use this apply method. And so this apply method allows you to create a custom function that returns either a true or false. And so I use apply, and then the custom function, the way I'm telling it I'm using a custom function, is that I start with this lambda. And so this lambda says this is a function of x. And what is the function? It just says the function is dop_in_x. So if dop_in_x, it returns true, and then if not, it returns false. And so what apply does is it does this for every single row, and it compares the gene name. So basically gene name, the gene name is sent to x, and so that is the comparison. And so you see we've created this array of Booleans, and so now if we send that into the slicing operator of the data frame, now we return all of the names that have DOP within it. So apply is also a useful way to kind of do these like custom. So as you get more used to this, you start to want to do more custom searching. So that, I think, pretty much covers it. And then the final topic we'll cover really quickly is iterating through a data frame. So when we have lists, when we had dictionaries, we talked about how do you iterate through every single element. So in this case, typically the way you would iterate through a data frame is you would want to go row by row and analyze it. So the best way to do that is to use this way, and sorry. All right, so what did I do? I said loop through every single row of this data frame, and I am using this iter_rows in order to accomplish that. So iter_rows goes through each row, and it creates a tuple for you, where the first thing, that element of the tuple, is the index, and then the second one is the record of data. So we start, we went through this once and then we broke, and so when we look at this, we're just looking at the first line of the data frame. So the index for this is 1, and now the record that's returned is this right here. So every single column and then value is listed kind of in a row. So if you wanted to access that individual data, then you can just use the dot operator with the column name, and then you access everything that you want. All right, so I know that this is a ton of stuff to cover, but Pandas is really one of the most useful ways to analyze data. And so the more comfortable you can get with it, the more successful you will be at analyzing biological data. So I really encourage you to put in this work and this effort to get as good as you can. And we're going to take a couple of classes to go over kind of some of all the different features.